Okay, the second type of Pythagoras' theorem problem is when we have the hypotenuse and one other side. So we have two sides, which is what we need, but we're needing to find a third side, one of either A or B, so one of the shorter sides. So we'll go through 3 examples now. This example here, let's write Pythagoras' theorem, c squared equals a squared plus b squared. Labelling our triangle. The hypotenuse is always C. The other sides doesn't really matter. Let's call this one A and this side B. So substituting in, C is 14, so 14 squared equals, keep it as A squared because we're trying to find A, and instead of B we write 8 and we square that. 14 squared is 196 equals A squared plus 64. 8 squared being 64. Our knowledge of equations is if we keep a squared here plus 64 here, let's take it over to the other side, and when we move sides we take 64. That leaves us with 132 being equal to a squared. We want a, so a is the square root of 132. Putting that into our calculator, square root of 132, I'll go up here for a bit more space. A is approximately equal to 11.489125529. Approximately, because it keeps going, our calculator screen just ends, so we have rounded it off. The question wants us to round it off further. It wants us to do it to 1 decimal place. There's 1 decimal place. Let's look at the number afterwards. That is greater than 5. Therefore, this 4 here goes up 1 to a 5. So A is approximately 11.5 centimetres. Let's look at the next example. The next example is very similar, except that it's a sentence and we have to draw the diagram before we can begin. This stage is really important. If we draw the diagram incorrectly, then we're not going to be able to get the sum correct. So a ladder is leaning up against a wall. So let's draw our wall. Let's draw our ground, and there is our ladder here leaning up against the wall. That's a right angle. You would assume the wall was at right angles to the ground. The ladder is 5.5 metres long. This is our ladder, so this is 5.5 metres. The foot of the ladder is 1.5 metres from the wall, so the foot is the base of the ladder. From the base of the wall it is 1.5 metres. How far up the wall does the ladder reach? It is wanting us to find this distance here, here to here. How far up the wall does the ladder reach? Once you've drawn the picture, I always recommend reading over the sentence again and just checking that you've got your picture correct, the diagram correct. If that is not correct, you are not going to be able to then get the sum right. So we have 2 sides and we're wanting to find the third side. It's a right angle triangle, so it's Pythagoras' theorem. C squared is equal to a squared plus b squared. Always write that down as your first step. Let's substitute in. C is 5.5, so 5.5 squared is equal to, calling this side A, this side B, so it's equal to x squared plus 1.5 squared, so we're substituting in. 5.5 squared is 30.25 is equal to x squared plus 2.25. We want just x squared on this side, so here it's plus 2.25, so we're going to take 2.25 from the other side. That leaves us with 28 is equal to x squared. We want to know x, so x is equal to the square root of 28. Putting that into your calculator. X is therefore approximately, because we've rounded off because the calculator screen ends 5.291502622. Let's read the question. It wants it to 1 decimal place. So 1, let's look at the number afterwards. That is a 9, which is greater than 5. So this 2 moves up to a 3. So x is approximately 5.3 metres. The question was written in sentence form, so your answer, therefore, you need one more stage. The answer needs to be in sentence form. The ladder reaches 5.3 metres up the wall. Okay, one more to look at. Okay, now this last one is harder, but it's Pythagoras' theorem. We're trying to find the value of x. Let's write down Pythagoras' theorem. C squared equals a squared plus b squared. Hypotenuse always c. This side can be a, this side can be b. So let's substitute in. C is 78, so 78 squared. A is 3x, so it's 3x and we need to square all of that. B is 2x, so it's 2x and we need to square all of that. When I square 78, I get 6084. When I square 3x, I get 9x squared, and when I square 2x, I get 4x squared. These are like terms, so I can add them and get 13x squared is equal to 6084. I'm wanting to find x initially. So this is 13 times by x squared. So I get the 13, move it to the other side and do the opposite. So it's 6084 divided by 13 is equal to x squared. 6084 divided by 13 is 468 is equal to x squared. And of course x is therefore the square root of 468. The square root of 468 is x is approximately to 21.633330.765. So that's what x is, and it wants us to find the lengths of the sides. Let's look at this side. This side is 3x, so side A is 3 times by 21.633330.765. Therefore, side A is equal to 64.89992296 to 2 decimal points, 1, 2, looking at the third. Okay, interesting. That's bigger than 5. So this 9 has to go up to a 10. So that changes to a 0, and then the 1 from the 10 moves this up to a 9. So A is 64.90 metres. Side B is 2x, so it's 2 times 21.63330765. So side B is equal to 43.26661531 approximately, because we have rounded that off. It wants it to 2 decimal places. 1, 2. Let's look at the third. Is greater than 5, so that 6 moves to a 7. So B is approximately 43.27 metres. Okay, so this video was 3 examples of Pythagoras' theorem finding the shorter side.